In this tutorial, what we're going to do is take a little look at another way of using loops in our programs. So what we've done in the past is we've actually used loops in every single program we've put together so far. We've always ended up writing while true somewhere, and then we write all of our instructions tabbed into the screen from that point forward to do all the different things that we've tried to work on. Now the thing about this while true loop is what this does is it continues to perform those instructions that you give it over and over again forever, and it never stops. But we don't always need to write loops that never stop, and sometimes, as we'll see, we want to put loops inside loops, which can make our programs even cooler as well. So let's take a look at a practical example of that right now. What I've done is I've taken this idea from the week 6 notes, and what I've done is I've put together the equivalent program in Scratch and also in desktop Python as well for us to look at. So let's take a look at this first. So what I did is I made a variable, I called it current number, you can see that just here, and what I then did is I said that when the green flag is clicked, we'll do that in a second, I want to have a forever loop, so these instructions here are going to happen over and over again, and they'll never stop, they'll keep running until I hit the red stop symbol. So let's have a look at what it is that we're doing repeatedly. So what I'm doing first is I'm setting current number to 0, so this has got the value 0 inside it, and I'm starting a new loop inside the forever loop. So let's have a look at what I'm saying. I'm saying that I'd like to repeat until the current number is greater than 4, so until the current number is 5 basically. What is it I want to do then? So what I'm doing is I'm saying very simply that I'd like to set the current number to whatever it currently is, but one more, so to add 1 to it. We've seen that done before in our MicroPython. So I'm making that go up. So if I was running this for the first time, it would go from 0, I'd be adding 1 to it, so current number would now be worth 1. What I'm then doing is I'm asking the cat to say the current number for 1 second, so I'll see a number 1, and then my loop bounces back up to the top. So repeat until current number is greater than 4. Well, current number is currently worth 1. So we're going to keep going. So we're going to add 1 more to it. So current number is now worth 2. We print out a 2. We bounce up to the top. Current number is worth 2. 2 is less than 4. We add 1 to it. It becomes 3. The next time it comes up, it'll be worth 4. Okay, repeat until the current number is greater than 4. Well, 4 isn't greater than 4, so that's okay. So we'd come back in here, and then what we would do is we would bounce back up to the top. Now this time it's a bit more interesting. This is the last time we're going to go around this. So as I look at it, I'm seeing current number greater than 4. Well, it's 5. 5 is greater than 4. So this particular loop is finished. So we drop out of the bottom. Okay, so we're down here now. But because we're inside this forever loop, what the program then has to do is it's going to come back up to the top of the forever loop, set current number back to 0 again, and the whole process repeats. So let's watch that work and see if that works as we predicted. So green flag clicked, cat says 1, 2, 3, 4, 5, and back to 1 again. Okay, and that's going to keep counting forever, and you can see that code there, and that's running. We'll never actually see a 0, the cat will never say 0, because even though it is temporarily set to 0, just here, even though it's temporarily set to 0, the first thing we do before we use the say command is we add 1 more to it, so we make it go up a little bit. So that's how we do that in Scratch. Let's put the Python code alongside that to compare it to now. So here's one I prepared earlier. Let's take a look at our code and see if we can see that these two things overlap and see how they compare. Well, because I wanted to use this 1 second delay after each time that I quote the number, I've had to start by importing time. Okay, you won't have to do this on the micro bit. But then let's look at the next line here. So I've got my while true, so that's the equivalent of this forever loop that we've got wrapped around there. And all the lines after that while true, they're all tabbed in, they're all indented just here, look. What's my next line? Next one is current number equals 0. Well, that's just here. Current number equals 0. And then the next thing we did is we started another loop, didn't we? Remember we started that loop there, and I can see that just here. And on this one, I've said while current number is less than 5. So while the current number is less than 5, keep looping and looping and looping. Scratch phrases it in a slightly different way. That uses the idea of repeating until something happens. So you're going to keep doing it until current number goes above 4, whereas in Python and a lot of programming languages it works the other way around. So we're saying keep going while current number is less than 5. So as long as the current number is less than 5, keep going. And you'll notice that all the instructions that come after that are then tabbed into the page. So that way I know which instructions are part of that. So let's look at the next part inside. I say here current number plus equals 1. So that's me saying that I'd like current number to be worth whatever it is now, but plus 1, which is this line just here. Alright, and then let's look at what's next. I'm then saying to print out the current number, and that's the cat saying the current number. Because I wanted this 1 seconds bit, what I've also got is I'm adding on a time sleep here to make it wait 1 second. And because that's the last of my instructions in my program, as soon as it's done that line, it'll jump back up here and it will loop through there to print out all the numbers I want until we hit 5. As soon as we get there, what it'll then do is it'll then come right back up to the top of this loop like this, and the program starts all over again. And we can watch this one work as well. I can run this program too, and you'll be able to see it down here, 3, 4, 5, like so. And that'll repeat and repeat and repeat, just like the Scratch version will. So 2 different ways of doing very, very much the same thing. So that's the basic idea behind using loops. And we can apply those in lots of different ways. We can say while, well, pretty much anything we want, really. As long as it's something that gives you a yes, no, a true, false at the end, then that'll work really well. So let's look at today's lesson. In today's lesson, what it asks you to do is to pick up this example code just here, which you can copy, paste, and then push straight onto your microbit. I'm not going to do that in this tutorial because that's just copying and pasting, and I think we've already covered that in quite a bit of detail. Let's scroll down the page a little bit further though. This animation's quite nice. You should take a look at this and you can get the idea of what we were talking about just a second ago. Anyway, moving on. Moving on. What I'd like for us to do now is to think about random numbers a little bit. So with computer games in general, they become a lot more entertaining to play if the way in which that the characters in games or the way in which you interact with the game is unpredictable and it changes a little bit. So that's where being able to pull in a random number becomes very, very useful. And thankfully MicroPython makes this quite easy to do. So what I'm going to do is I've got this example code here. It's under the Lucky Dip heading at the top of the page. I'm just going to grab that code and I'm going to copy it. And I'm going to go into Mu, which I've got open, and we'll paste that in. Okay, let's take a second and look at what we've got here and see what's new. There's elements in here we will recognise, like we've got the while true. You'll probably recognise there's a variable being assigned. There's another loop here. But let's take a second and look at this. So from the top, first line, that's standard. We've talked about that every single time. That's just bringing in some extra code for Python so it can work with the microbit a little bit better. What we've then got is another new line that we haven't seen before. This is import random. This is bringing in some extra code which allows us to work with pseudo random numbers, numbers that look like they're random. What's our next line? Now this one here is quite important. On a microbit, what you do is you have to run the computer's random number generator. You have to sort of prime it ready to be used. And so we use the command seed in order to do that. The easiest way for you to think of it is it's a little bit like taking a dice that you used to play a board game, putting it into a cup, then giving it a good shake. That's what's happening, so it's making it to help to randomise the outcome and you get more unpredictable results. So you just make sure you use that. You won't see anything happen, but it will happen inside the microbit. And next line then is a while true, so we're setting up a new loop here. That's why all the commands underneath it are all tabbed in from that point forward. So the next line, this is the one that's genuinely new for us. So we're saying we have a variable called target number. You can call yours whatever you like, of course. But we've got target number, and I want that to be from the random library. I'd like it to be a random integer between the number 5 and the number 10. So as soon as I run this line, target number is now a bit of a mystery. Maybe it's 5, maybe it's 6, 7, 8, 9, maybe it's 10. We don't know. It's a random number. But that's what makes it really, really nice. It makes it unpredictable. So let's have a look at the next line. So what we've got here is another while loop. This is another way we can do this. And what I'm saying is I'm going to say that while the target number that we've chosen, our random number that we chose, while that is larger than 1, we're going to do these things. So let's take a look. So the first thing we do is we take 1 away from the target number. We're doing that minus equals 1, aren't we? So we're making it go down. So if, for example, the number that we had chosen at random was 5, then it's now worth 4. We've made it go down by 1. And then what we're doing is we're going to show on the display the target number. So if it had been 5 and it was 4, we'd see a 4 on the screen. That's the end of that loop, so we're going to bounce back up inside that loop. So is 4 greater than 1? Yes, it is. So we'll take 1 away from it. So it's now worth 3. And then we show a 3 on the display. Then we come back up. Is 3 greater than 1? Yes, it is. We take 1 away. It's now worth 2. We then show that 2 on the display. Is 2 greater than 1? Yes, it is. So we take 1 away. Target number is now worth 1. We show a 1 on the screen. We come back to here. Is 1 greater than 1? Well, no, it isn't actually, is it? So, so at this point, what we do is that while loop is actually finished, and there's nowhere else to go, but we are inside a while loop, aren't we? So all these instructions here, all part of this while true loop that will never ever stop. So the next command that gets run is this one just here. So target number is a new random number. Maybe this time it was 10, something like that instead. And then we start this loop all over again while 10 is greater than 1, and we'll watch it count down from 10 to 1. New random number, it'll count down from that down to 1, and it'll keep going. So that's the way that this particular program would work, using those while loops. Now, this takes us on very, very neatly to the badge tasks for today. Your badge tasks are to take this pseudocode just here and to try and write that as a Python program. And this one doesn't actually use random, this one just uses loops, so hopefully you might be able to feel confident to try working on this. My little top tip to help you is just keep an eye on your tabs, keep an eye on your indentation. So for example, you've got a while loop that you'll write just here, so you'll have to tab into there, but when you start this while loop, you have to make sure that's tabbed in to that same level like that. Don't tab that in again, is what I'm saying, because you end up with your program not quite working how you intended. As always, do experiment, try different things, keep pushing it onto the micro bit, just keep trying, because even if you make mistakes, if you look at the result you get and you try and understand what's happened, that'll help you to really improve as a programmer. Quite often when things don't work, we learn the most about our coding. So if you manage that, there's then a nice gold task which you can do, a little reaction game which will be really good fun, and then finally you can make your own version of Bop It for the platinum badge if you're feeling a little bit more ambitious. So have a go at those and let's see how you get on.